Well, hello there. So we've been studying our triangles. We have worked a couple of days in figuring out how three sides can form a triangle and whether or not they actually make a triangle. Today we're going to push that a little bit farther. We're going to watch this video. Please follow along with your guided notes and examples that I provided for you. And then tomorrow, be prepared to take a quiz on the following video, just so I know that you were actually successful in working through these examples with me. This should be more or less a review for you. We're going to be looking at the Pythagorean theorem. This should be a refresher for you. We're going to take it into more detail tomorrow. So our goals today are to figure out what is the Pythagorean theorem. That should be a refresher. And this is where it goes a little bit in more depth. How will Pythagorean theorem help us learn more about triangles? Here he is, Pythagoras. He is a Greek mathematician who developed the Pythagorean theorem. He discovered it, I should say, and we use it in almost every math discipline. It's probably one of the most prominent theorems that you'll be studying in any math class. So we're going to take a look at it right now. The Pythagorean theorem, if you recall, is a squared plus b squared equals c squared. So what does that mean? Well, here I have a right triangle. I'm going to sketch one in right here. Okay, here's my right angle. Usually we call the two legs A and B, and the hypotenuse is C. Okay, that's just so we have consistent language throughout. So when I'm talking about a squared plus b squared, I'm talking about the legs being squared and added together. And when I talk about c squared on this side by itself, I'm talking about the hypotenuse of that triangle. Now, the only types of triangles that have legs and hypotenuse is a right triangle. Notice even that detail in there. So this has to only work if a triangle is a right triangle. So how we're going to use Pythagorean theorem today is to help us test to see if indeed we do have a right triangle or not. If we do, this formula will check out. And if we don't have a right triangle, you're going to see something's going to go wrong with the numbers when we fill it in. But let's take a look at our first example to see what that's going to entail. So in example 1 here, they want us to determine whether the given triangle below is a right triangle. So of course they don't give us any details here where like a right angle would be drawn in. You could sketch one in if you want, even put like a little question mark there because we're testing to see if the right angle would fall there. So what you have to do is you have to take the two shorter sides, the two legs, and we're going to do a squared plus b squared and see if they equal c squared. Okay, square root of 113 is definitely the biggest number here, so that's going to be on the side by itself. So equals the square root of 113 quantity squared. I'll talk about how we could deal with that in a second. Then it doesn't matter what you assign A or B. I'm going to do 8 squared plus 7 squared. We're going to be squaring and adding them anyway, so it doesn't matter the order right now. 8 squared is 64. 7 squared is 49. You could have your calculator handy if you need it. And remember the shortcut. We looked at this in the beginning of the school year. The square root of 113 squared just gives you what's underneath that radical. So we get 113 on the side by itself. That was a shortcut that we had studied before. 64 plus 49, I would punch that into the calculator. That is 113. And look what we got here. 113 equals 113. So we can determine at this point to actually answer the question that this is a right triangle. Okay, it's a right triangle because it checks out with Pythagorean theorem. And that's as simple as you can get it. All right, let's take a look at another example together. So if you look at this question, sometimes they're going to start including different skills all in one. So this first question in example 2a is determine if the following segment lengths form a triangle. They don't want to know if it's a right triangle right now. They just want to know if it's a triangle. So that means this is actually a triangle inequality question. Triangle inequality theorem, which we looked at a couple of days ago. Maybe Pythagorean theorem will come after, but right now we just want to know if it's a triangle. So that's triangle inequality theorem. And if you recall how to do that, all we have to do there is take the two shorter sides, so that would be 10 and 11, and see if they add to a number greater than the third side, the largest side. So 10 plus 11 is 21, and that is greater than 14. So yes, this is a triangle. You always want a sentence to make sure you actually show what you were asked to show. So that's what they asked in A. You really want to make sure you're reading for details here, because now in part B they're saying, if yes, determine if the triangle is a right triangle. So now this is Pythagorean theorem. So whenever you see that language, right triangle, that's when you're thinking Pythagorean theorem. If it's just triangle, it could be something else. So read carefully. So remember, a squared plus b squared equals c squared. I'm taking my two shorter sides as my legs. That's 10 squared plus 11 squared. And I'm testing to see if they're greater than the third side. That's 14 squared. So these square roots we know are 100, 121, and 14 squared is 196. Okay, just keep working the arithmetic through. We get 221 equals 196. That doesn't work out. So because the numbers fell apart, because something went wrong here for us, we know that this is not a right triangle. And we had to use Pythagorean theorem to help us reach that conclusion. It is a triangle, it's not a right triangle. And tomorrow in class, we're going to look at different cases where we can determine through Pythagorean theorem if it's acute or an obtuse triangle. But right now we're just figuring out if it is right or not. So don't worry much further than that. Those are the two examples I have for you. Remember, tomorrow we are going to have a quiz if you can quickly do these skills of Pythagorean theorem. It shouldn't be anything too difficult. But if you would like to have these practice problems at your disposal, they are included in the notes that you're working on right now. You can check the key, and that will help you prepare for your quiz tomorrow. Have a good day. See you guys.